Welcome to aminacademy.com. In electrical engineering, let us discuss about electron drift velocity. What is electron drift velocity? The drift velocity is the average velocity that a particle, such as an electron, attains in a material due to an electric field. It can also be referred to as axial drift velocity. In general, an electron will propagate randomly in conductor at the Fermi velocity. An applied electric field will give this random motion a small net flow velocity in one direction. Let us understand this first by using some figure here. Suppose this is a conductor, positive or negative side. This here, this is electric field. This is electric field E. Electric field E here. Now consider a drift here, velocity of the electron, that is Fermi speed of the electron. Let us indicate by using some arrows like here. Like here, these are drift velocity. Therefore here drift velocity is here. Here the electron moves at the Fermi speed and has only a tiny drift velocity superimposed by the applied electric field. Now we'll get the speed of the electron drift velocity. We will prove this. Suppose a conductor, there are number of free electrons. The volume of the conductor now, volume of equal one meter cube there are number of free electrons. There are number of free electron equal n. Then axial velocity of these electrons is equal to v meter per second. In time delta dt, the distance traveled would be, we know that distance equal speed into time, which is equal v dt, v into dt. If A equal area of the cross section of the conductor, cross section of the conductor of the 1 meter length, Therefore we can say not 1 meter length, just A equal to cross section of the area of the cross section of the conductor. Now we can say volume of conductor equal distance is V dt and area is A. Therefore V A dt. Suppose all this electron will cross the conductor cross section in time dt, then we can say, now let E equal to charge of each electron. Therefore we can say, now charge of electron is E is the charge of each electron in coulomb and dt is the time. So we can say then dq now total charge the total charge which crosses this section in time, which crosses the cross section of the conductor, equal in time dt is equal n a e v dt. This is the total charge which crosses in time dt to the cross section of the conductor. Now the current, we know the current is charge by time. So charge we have n a e v dt over dt, then dt cut we can get n a e v. Therefore I equal, the current I equal n a e v. Now current density, which means current by area, of the cross section, that is I over A, is I is already n a e v over A, and A and A cut, we get current density. We can use it, current density as J is NEV ampere, unit is ampere per meter square. Now we got current density J equal to NEV ampere per meter square. We have done.